Hi, I'm Sami Kuba.
And I'm Kelly Akins, Program Manager for Incident Readiness.
And I run the Azure Communications team. Our team communicates to customers during impacting events. This could be a maintenance, a retirement of a feature or a service, or in worst cases, an impacting incident. Now, these incidents are inevitable, but impact to customers doesn't have to be. These sessions will walk customers through parts of our well-architected framework, whether it's taking advantage of the resiliency options that Azure makes available to customers, or the best practices for your application once they've migrated from on-prem into the cloud, or even troubleshooting your environment.
That's right. So we're here to translate those readiness recommendations into practical, actionable solutions to help you prepare for the unexpected, with our ultimate goal of helping you minimize or even prevent the impact of incidents. So we hope you enjoy the conversation. Thank you. So, hi and welcome everyone. As Sammy mentioned, this is our second Azure Empower Platform Incident Readiness session. I'm Kelly Akins. I think I already said that, a technical program manager focusing on Azure outage communications and incident readiness. And today, I'm delighted to co-host this session with you with Sammy Kuba. So our theme for today's session is ensuring your mission critical resources are zone resilient and secure. We'll start by discussing the shared responsibility model and what drives the framework for these sessions. Then we'll explore Power Platform's journey towards enhancing the resilience of their Azure services using availability zones. Then next up, using Azure virtual machines and Azure disks, we'll show you how to assess whether resources are zone resilient and redundant, and if not, we'll demo ways to make that happen for you. Then pivoting to our security chapter, we'll show you some conditional access policies that will raise your security baseline. Finally, we'll discuss best practices to keep in mind from the Azure Well-Architected Framework. Sammy, over to you.
Super, thank you very much. I wanted to take a couple of minutes to intro the session. I run the Azure Communications team, and so reliability is a subject very near and dear to my heart. One of the key messages that we try and land with customers is that reliability is a shared responsibility. And looking at kind of the graph or the slide in front of us now, there are things at the bottom that Microsoft takes care of. This is how we run and it's how we operate our data centers. But really the intent of all of these sessions is really about the middle two pieces. And the middle one, the middle and the top rather, the middle one being around the options that are available to customers to make their mission critical or their very important workloads more reliable. And I think the intent of this session is to show what exists on the buffet for customers and what are the things that they have at their disposal. And then really lastly at the top, this is really a customer responsibility where it's really important that customers just don't take an attitude of lifting something from their on-prem, from their EMC or their sandbox, throwing it into the cloud and expecting that same level of uptime or reliability or resiliency. Applications need to be architected to be cloud savvy. If we move on to the next slide and we ask ourselves, well, how reliable is Azure? Well, it's a tough question and it's very nuanced. If we take the availability of a VM in Azure, we're typically running at about 4 nines and a 7. Now, 4 nines and a 7, it equates in under 12 minutes of downtime in an entire year. And some people might look at this and say, 12 minutes of downtime in an entire year, that's amazing, I'll take it. But that 12 minutes of downtime in a year could be one session of a 12-minute interruption for a year, or it could be something which is a little more inconvenient, which is every month there's a 1-minute interruption. Or it could be even worse, where every 2 to 3 weeks we have a 30-second interruption. And that 30 seconds is enough for a virtual machine to disconnect from a SQL database, and it's enough to kickstart a restart of the customer's application. And so now we're getting into a problem where every 2 to 3 weeks we have a bit of a bump in the road, and then when people come and say, what's going on, this is a terrible experience, people boast 4 nines and a 7 and 12 minutes of downtime in a year. Now, fortunately, that doesn't happen in Azure, and we don't have these interruptions periodically every 2 or 3 weeks. But it is important to understand that reliability and availability are nuanced. And even though the numbers can be very, very small, we're talking about 0.0002% or 11 minutes of downtime a year, those 11 minutes need to be well prepared for. We need to understand that even though it's small in number, it can have a larger impact in our workloads and how we think about it. So as we move on into the next slide, it's really important to understand that this 0.002 or this tiny little bit is orchestrated predominantly by change. And change is a wonderful thing, and it's an important thing, and it's a critical piece of managing our cloud infrastructure. It used to be, once upon a time, I remember I was speaking to a customer, and the customer was contemplating whether they should come to the cloud, and they would look at the 4 nines at the time and say, I mean, Sammy, 4 nines, I have a 100% uptime, and this was their primary metric. And it was impressive, and I'd say 100%, that's incredible. And we would walk around their organization and speak to different departments and groups in the organization. One of the first piece that struck me was their security team, and their security team were very panicked because they said, listen, we haven't been patched in years. We're still kind of open from spec to meltdown. And, they're very nervous about what had happened because, they hadn't had time to patch. And then as we were speaking to users within the organization, they were very frustrated about using antiquated software, or they weren't up to date with the latest and greatest. And so kind of that compromise of having a 100% uptime, which sounds wonderful, but there are risks that come with it, is something we try and delicately balance, and we walk a fine line. And so when we think about the 0.002, or the small minutes of downtime per year, that's generally introduced because of change, and changes to keep customers safe and secure. We want to make sure we're shipping the latest and greatest features, and want to make sure that generally customers have a fantastic experience in Azure, but we don't want to make changes all the time. So the way we make change, if we move on to the next slide, is for our safe deployment practices. It's a very oversimplified version of what happens. Typically, we have a validation cycle, but as we deploy changes in Azure, we do this in a very staged approach, where we kind of deploy to one server in our canary regions, and over time, that deployment will double and double again. It'll go to multiple servers and servers. All the while, we're monitoring for any anomalies, any errors, any API failure calls, and so on. This process takes a very long time deliberately. And what happens is when we're making these updates, we don't update availability zones at the same time. So if customers are using zones and there's bad code that's kind of brought down one zone or impacted one zone severely, customers leveraging zones should be fine. And we don't update our region pairs at the same time either. So if customers do have some sort of BCDR and continuity plan, they can make sure they're leveraging their region pairs. The interesting piece to note at the bottom, on the very bottom where you've got the blue to red arrow, is over time, the impact of this change can be felt significantly. Now, fortunately, the overwhelming majority of incidents that we have, or interruptions that are caused by change, are very, very small in number. They can fit on 1 or 2 hands in the number of customers that are impacted. We don't have a threshold for when we declare an outage and communicate to customers. It could be 1 customer, and oftentimes it is. But the way we deploy change, the way we introduce change, whether it's performance optimization, shipping new features, security, keeping the world safe, all of this is done through our safe deployment practices in a very staged approach. If we move on to the next slide, I just wanted to kind of talk about that and how we introduce change and why it's important, and those little bits of downtime. But really the entire session, you don't have to wait for these quarterly sessions in order to get the best practices. We have documented all of this in the Well-Architected Framework, but these sessions are really going to focus on the reliability and the security components of things. And I think our first speaker here is Tim. Tim Roberchet runs our Power Platform, or he works in our Power Platform service, and Power Platform have gone on their own reliability journey, and they've been leveraging some of the themes from the Well-Architected Framework. So Tim, I'll hand it over to you.
Thank you, Sammy, for the fantastic handoff. My name is Tim, and I lead the team responsible for the Power Platform communications related to service events and change. I'm thrilled to say that Dynamics 365 and Power Platform is one of the biggest customers of Azure today. Power Platform is made up of more than 400 individual microservices that are running in Azure. And on the storage side alone, we're utilizing over 13,000 SQL Elastic pools with 3.5 million databases and 24 petabytes of operational data. We're making use of hundreds of millions of Azure resources. For example, the Power Automate service uses over 45 million Azure Logic apps. As we transition into the next slide, we also want to call out just how Power Platform infrastructure is expansive in breadth, not just in depth. We have 68 distinct components that are all built on top of Microsoft Azure. And this has enabled us to scale our capabilities rapidly and effectively using that shared reliability, the shared responsibility model for reliability. We believe this is something that would not have been possible without the use of Microsoft Azure. And with this list of services, we've needed to apply principles of good fault-tolerant architecture to our design and incorporate those shared responsibilities to deliver on our reliability goals. Talking briefly on the next slide about the principles of good fault-tolerant architecture, we really want to focus on minimizing risk, breaking up the fault domains, and assuming fault. We minimize the risk because product groups tend to optimize for success by adding more features. As Sammy mentioned, we really want customers to be getting the most secure things and be as productive as possible, getting the latest and greatest. But our good architecture should also minimize the risk as well. When we break up the fault domains, faults are an unavoidable part of a complex system. All software has bugs of some sort. It's not a matter of if a fault will occur, but when. Therefore, it's essential to be prepared to minimize the impact of those faults. And the best fault-tolerant system should not allow for large fault domains or cascading failures that transition from one component to another. The last piece here is we say assume faults because we know that certain components can be faulty. We just said that. There's unavoidable. So it's important to consider how we compensate for this. We can add redundancy, change patterns to loosen dependencies. We can move operations to the background. To ensure good fault-tolerant systems, we should expect the faults at every component and have a corresponding compensation logic in place. Moving on to the next slide to look at how we practically apply these principles, we have been building a core services platform to help standardize the technology and key operational processes across the Power Platform. We identified the critical services back from that slide with those 68 services that sit between Azure and the Power Platform applications, and we built an infrastructure which all teams use to build their services. This core services platform is very opinionated and structured for how we build our software, and it's a concept known as platform engineering. This platform engineering streamlines our infrastructure to the needs of the business organizations and creates a consolidated set of resources that we can go scale very quickly and efficiently. Switching now to the resiliency journey. Over the years, we've launched many programs and initiatives to identify key areas of improvement. And in the last year, we introduced kind of a meta project or a super project called Project Standard. This is to help us continue that standardization journey across our technology and really identify the key operational processes across Power Platform. The project standard now has many themes like isolation or data integrity, which target different aspects of the platform to go deliver on those reliability principles, those good fault-tolerant principles, and group them into themes. By providing this standard set of tools and services, the platform engineering we do can help ensure the consistency, reduce duplication of effort, and improve efficiency. And this platform engineering is now a continuous process of refining and updating the platform to meet, new standards, leverage new technologies, and always be improving the performance and security of our product. So let's now start diving into the internals of the architecture and look at the first theme of Project Standard called isolation, and then we can talk about zone redundancy after that. There is several different applications of the isolation principle that we use. And the one we're going to focus on today is where we take our topology and divide it into these three subunits, which we call planes. Each plane represents a portion of our service with a specific purpose. The control plane is responsible for building out new infrastructure and managing it, which includes the two other planes, the management plane and the runtime plane. The control plane breaks up the fault domain by splitting it by splitting out the provisioning of the Azure resources, building the compute clusters that we use to process data, and deploy services to these clusters. Within the runtime plane, we break up the fault domains by splitting it into a cell architecture called islands, which contain the majority of customer functionality. Most of your interaction with Power Platform is through services on the runtime plane like Power Apps, Dataverse, Power Automate, and more. So here we're showing that we're continuing to try and reduce the size of the fault domains to get as small as possible to limit impact of any faults that enter into the system. So as we kind of switch gears from talking about how we've broken up the broken things up to build that false isolation, on the next slide, or on this slide, I want to give a brief overview of Azure availability zones. In simple, terms, regions are made up of data centers, sometimes one, sometimes 15 or more. And some of those regions support availability zones where the data centers are divided across separate facilities, each with independent power, networking, cooling, and it's all separated from each other. So when you're using them for high availability or disaster recovery, the availability zones reduce the risk of putting all of your eggs in one basket, to use a colloquialism, and distributing those resources to different places that are designed not to fail at the same time. So with that kind of overview of, very basic overview of availability zones, the reason why the next slide talks a little bit about how we are leveraging those zones. As part of this as part of this isolation, we mentioned the Power Platform topology with the 3 planes and islands and the runtime plane. We take these planes and the islands and deploy them across 3 zones with the synchronous replication of the data. And since that replication is synchronous, any failure in a zone or loss of a zone completely, the customer traffic will be seamlessly redirected and automatically moved to the other zones, so customers won't see an outage, they won't see an impact. On the next slide, though, we really want to say building resilient services is about layering. It's about making sure that you are taking steps to keep the platform reliable despite what type of fault that you're seeing. As part of the shared responsibility model, there are some aspects of our resiliency strategy that we've layered in our space, adding or including asynchronous replication to another region to provide that redundancy in case of a catastrophic outage or major disaster, which impacts all 3 of the zones. Those are very rare, but we want to still protect the experience and customer data from those happening. In such an event, we're able to fail over the customer workloads to a secondary region to restore service for customers and provide that disaster recovery. And there are some risks to using asynchronous replication, but the latency between regions can be large, as many regions are typically 300 or more miles apart. And if we had synchronous replication both within the availability zone and these replication partners, it would have significant detrimental impact to the performance of our service. So now on the next slide, the kind of question is, how do we deliver this change to a live service? How do we keep the ship of Theseus floating? Well, we do this by enabling zone redundancy for all of the compute clusters first. We take that compute component where the processing is done across those more than 60 Azure dependencies, and we make those zone aware. Next, we need to make sure that our migrations are online so customers can continue to leverage the services while we migrate the resources underneath the covers. To do this, we've been collaborating with teams across Azure and Microsoft to develop online migration solutions for those dependencies. Finally, there is a subset of customer workloads that are deployed to regions that are not zone enabled or don't have that redundancy available. And we're moving those into other regions and other environments with that zone redundancy so we can provide this level of reliability across the entire Power Platform. So now that we've talked a little bit about our reliability journey and how we're leveraging availability zones, I'm going to hand over to Kanika so she can show you how you can access your reliability and assess your reliability and security posture. For our upcoming reliability section, there's a demo that'll cover 2 mission critical resources types that leverage Azure Virtual Machines and Azure Disk Services. Kanika?
Thanks, Tim. Hi, everyone. I'm Kanika, and I'm from Azure Advisor team, and I'm here today to provide you a quick walkthrough of Advisor, which can help you take better informed decisions. So as cloud computing is becoming more and more common nowadays, we totally understand it's very crucial for you to have infrastructure and cloud workloads which are more efficient and which are more cost effective. So I hope you can see my screen there, where I'll give you a quick walkthrough of Advisor. So Advisor service is available for all Azure customers. And as you can see, the Advisor product provides you best practices such as recommendations across all 5 pillars of well-architected framework that are cost, security, reliability, operational excellence, and performance. So Advisor will give you best practices recommendations, what you need to do based on your resource configurations across all these pillars. So as we are talking about reliability today, let's take a first step there. So if you go to the reliability pane, you get to see the reliability recommendations which are applicable for your already deployed Azure resources. You can definitely filter out the subscription based on the subscription scope and other filters as well. For all those recommendations, you can see what is the impact of the recommendation, high, medium, or low, what is the description, and what is the potential benefit that you'll gain after adopting this recommendation. So let's take an example of a zone resilient recommendation. As we have been talking, we have been understanding why zone redundancy is very much beneficial for high availability and fault tolerance. Let's go and have a look at one of the recommendations for virtual machines. Use availability zones for better resiliency and availability. Once you click on the recommendation, you get to know the details about the recommendation, and definitely a list of impacted resources comes up. And as I said, the scope depends on your selected filters. So here I'm getting the list based on my selected subscriptions in my Azure. So you can see what are the deployed resources which are getting impacted by this. Based on the configuration of the resources, these recommendations are generated. Then there's a recommended action. So overall across Advisor, recommended action can guide you to either one of the two places. One, it can either guide you to a documentation guide. Like if you click here, it will take you to a documentation guide, which will list down the steps, what you can take to actually adopt the recommendation. The other option is it will either redirect you to some place in the portal where you can take, with a few clicks, you can actually adopt the recommendation. We'll see that example as well. So this is about how the recommendations look like, and we will have Dave in the later session who will actually guide us with step-by-step how to adopt these recommendations. So talking about the other example, let's take the example of disk. So there is another recommendation: use Azure Disk with Zone Redundant Storage, that is ZRS, for higher resiliency and availability. So if you click here, similar to the previous recommendation, you get to see the description, the impacted resources, and the recommended action. Here, when you click on the recommended action, you get to a different place in the portal where you can actually change the configuration of your disk to adopt this recommendation. So here you can see you can actually choose one of the ZRS options to adopt this recommendation. So overall across Advisor, you can see for recommendations that have recommended action, either redirecting you to a document or another place in portal. And we totally understand adopting resiliency recommendations comes with a cost. And in some cases, you might feel like this is not the resource I really want to invest money into, and I'm fine letting go of reliability for this particular resource. Advisor also provides you the option of postponing or dismissing the recommendation for those resources if you want. That being said, while cost is one of the factors here, it's generally, to be considered as an investment because it actually helps you improve the performance and availability of the resources. And anyway, when you're deploying your resources across a workload for an infrastructure, there are different parameters to be considered. Cost, reliability, trade-offs also happen. So we also have Ben, who will be covering WAF assessments, which actually help consider these all factors into place while designing our workloads and infrastructure. This was about reliability recommendations and Advisor. Similarly, we have operational excellence and performance, which also have potential benefits listed with the recommendation. We have another section, which is for cost recommendation, which actually calls out what is the potential yearly saving based on if you adopt those recommendations listed. And the last pillar of WAF, which is security. So security recommendations are in sync with Defender for Cloud, which is a platform which helps you with the security best practices that helps you provide, helps you provide security from any vulnerabilities or cyber attacks for your resources. So here is a list of those recommendations. And of the very, very crucial ones, the security recommendation is to have MFA enabled for your resources. We will have Shweta cover up the details also on how you can actually adopt those recommendations, but you can actually see the list of all recommendations coming up here. And once you click on those recommendations, similarly, you get to see the impacted resources and how you can actually resolve those. So this was about Advisor, the overall recommendations, the details you get to see. And as I said, Dave will be helping us understand how you can take steps to actually adopt the recommendation. So handing over to Dave.
Thanks, Kanika. My name is Dave Newman. I am a senior CSA here at Microsoft on the infrastructure side of the house. I've been working for quite a while with customers helping to deploy resources into the Azure environment, and happy to do some demos for you today on how we can take action on the recommendations that Kanika has mentioned. So I'll share my screen real quickly, and what we'll take a look at here is, again, back into Advisor. We want to know how we can actually do something about these recommendations. As she mentioned, and we're going to look at disks first, the ability to make a change here just allows you to come along and grab a particular disk and quite literally follow this recommendation where it takes you into the actual disk itself. Right now, this disk is configured as locally redundant storage. If you're not familiar with our storage process, locally redundant storage, or LRS, means that there are 3 copies of that disk that live in different storage environments in the same location. They're in the same region. They're in the same data center. The option to move to zone redundant storage, or ZRS or ZRS, depending on your pronunciation of that letter, is a very simple thing to do. But what happens when I make this switch is that those 3 copies are now distributed not just among different storage environments, but across the 3 different zones that exist inside of that particular region. And it shows right now that this process is actually already done. It's a very quick thing where it says that it updated the disk. In the background, it's actually running a process right now where it's copying that data to the different zones that exist inside of that particular region. Now, this is a portal process for doing this. We can do the same thing if you're doing any kind of infrastructure as code. For example, here's a little bit of Terraform that we can look at, a very simple structure that built out an individual standard solid state. Well, actually, this disk originally was an LRS disk. When it was built, if I want to switch this one to being ZRS, it is quite literally as easy as just making that change, and then making sure that we save the file. And then if we run a Terraform plan against that, I was going to run this thing as a sample. That's the way that Terraform functions. It's going to go ahead and it's going to do the exact same thing that we just saw in the portal, but it's now doing it through an infrastructure as code process instead of through the portal to accomplish the same thing. The plan process does take a moment or 2 here, so we'll just let it finish. But it will show when it comes up that it'll be doing what's called an in-place upgrade of the disk, and it will show it's going to convert it from being an LRS to a ZRS disk. And this is taking a minute longer. There we go. So we can see here that it is going to be doing an update in place. It is going to be converting this disk into a standard solid state ZRS disk. And if I was to run a Terraform apply, now it would go ahead and it would make that change. So there's a number of ways we can accomplish the same task. But making sure that our disks are available and distributed across multiple zones within a region gives us that higher level of resiliency and availability. The other piece that we wanted to look at today was virtual machines. In the realm of virtual machines, we always want to try to have an opportunity to have multiple instances of our virtual machines deployed across multiple availability zones. That way, if we lose a zone, we don't lose our application. There's another instance of that application available and can run that way. As Kanika mentioned before, this particular one takes you to documentation. It doesn't take you to the portal right away that will allow you to jump in and make the change directly. What it gives you is instruction. The instruction here for how to take an existing, what we refer to as a regional virtual machine that's been deployed into a region, not into a specific zone. The way that we turn that into a zone-specific virtual machine right now, the currently generally available supported process is a redeploy of that virtual machine. Currently, the way that you would do that is that you would start off by creating a snapshot of the disks that are a part of that virtual machine. And then from those snapshots, you would then create a managed disk from the source disk. So you can take that snapshot and make a new operating system disk out of the snapshot. And then from there, you create a new virtual machine based off of that new operating system disk and any other disks that you might need to. So you build up a new VM based off of that process. This page has some examples of how you would do this from a CLI perspective. I actually have some PowerShell that is set up to run the same process. I'll bring this over. And so from a PowerShell perspective, what we would need to do first off is, let me clear that screen. Oops. That's not what I wanted to do. Apologize, folks. It's in the wrong screen. Let's do this first. Okay. So I've already taken a snapshot of the disk. I did that ahead of time, so we don't have to worry about that. The snapshot is called Demo Snap 1. What I want to do now is I want to create a new disk, a new OS disk for a virtual machine. And so I'm going to create a new disk with a new name, its size, and then I'm putting it into a specific zone. So I'm creating a disk that goes into a specific zone. And what I would need to do here is just run this PowerShell. This one is going to be, I want the OS disk from snapshot PowerShell script. And this will go ahead and it will create for me, based off this PowerShell, a new OS disk. And that new OS disk, that's finished, is going to then be used by another script that I've got here that is going to create a new virtual machine. Wait, did I do? That was 2. I need to change this to match. So I need to make this 2. And create a new virtual machine named test VM2 in zone 1. Save that change. And then it's going to go ahead and create a new virtual machine that is now going to be located in zone 1, but is going to have all of the same disks as the original VM had, so it's the same functionality. We just need now to have the virtual machine created from that operating system disk. Now, one of the issues that we have to deal with when we work in this process is that this is creating a new virtual machine. My old VM is still running, so I'm creating a new system that is running in parallel with my old one. What I will eventually need to do once the virtual machine is built is that I will need to go and I will need to remove the old virtual machine. And then I'll need to change whatever process is used to access that VM to point to the new virtual machine name, whether that's going to just be a DNS CNAME alias record you create, or whether it's a change in the, if there's a load balancer on the front side, just a change in that. This this process will create a secondary VM that will sit side by side with the original, and then we need to adjust the other one. Again, right now, this is the currently approved, generally available, supported solution for making this change. There is another way that you can do this that's a little bit neater, a little bit cleaner, that exists today, that is currently in preview. And so just be aware that what I'm going to show you right now is not a generally available solution yet. It will be coming some point soon, but it's not quite there yet. If we look at an existing virtual machine, this virtual machine, as we can see, if we go down here, is not set up in any availability zone. It's not in an availability set. It's just what we call a regional VM that is sitting in West US 3. It is in a zone, but I don't know what zone it's in. When I choose to deploy this VM, if I don't specify, we pick in the back end what zone it's going to go into. If I wanted to specify and be able to know what zone it's in so I can distribute multiple instances of this environment across zones, I can do that through the portal. I have an option in the virtual machine itself, an option in here called availability and scaling. With availability and scaling, I can go ahead and kick off a process. Actually, let me grab a different VM to do this with first, because this one's going to be at a different spot. Do the same thing. With availability and scaling, I'm going to start this process here, get started. And the first thing it's going to ask me is, what zone? I pick zone 1, zone 2, zone 3. Within a region, I can choose whatever zone I would like that virtual machine to stand up in. I do need to ensure that I have the ability to create a system-assigned managed identity in my tenant. If the person making these changes doesn't have the ability to create managed identities, then they will need to have that permission for this to work. So I'm going to go ahead and say next on that. And what it's going to now do is it's going to go evaluate the environment. It's going to create the identity, and it's going to retain the source virtual machine name. So I'm not building another VM that's going to run in parallel. This is going to be the same system with the same name in the same size. It's going to go into an availability zone. It is going to create a new NIC, but it will be in the same network. It'll be in the same VNet. It'll be in the same subnet. All that information will be retained as a part of that process. If I kick back out of this real quick and look at number 4 again, and this one's already ready to go. It should come back up with all of the details. Yeah, so here we can see that this is the original name of the VM, the new name of the VM, the old NIC, the new NIC, and now I've got the same subnet, the same VNet. I can change those if I wish, but otherwise, all I would need to do is push the validate button, and it would go and it would make that change, and it would actually convert this VM to being a zonal virtual machine as opposed to being a regional virtual machine. So this has been an example and some demonstrations on how we can take resources that have not been deployed into zones and be able to move them into and make them available as availability zone resources, and be able to make those changes effectively from the telemetry that we get from our Azure Advisor environment. I'm going to hand things back off to Kelly, and we'll continue on from there.
Very much, Dave. I'll pinch the microphone if I can for a second. I really thank you very much, Tim, Kanika, Dave. But just as we close the chapter on our kind of reliability section, we're going to move on. A reminder, we are speaking at different altitudes about different topics, but our Q&A moderators are all standing by, so please do leverage them. I know some folks are asking questions, but please, we have that Q&A open, and it's going to be remaining open for the remainder of the session. Kelly?
Yeah, thanks so much, Sammy, and to Kanika, Tim, and Dave. What a great reliability session. So now switching gears to our security chapter, and Swetha's up next to show us some conditional access policies, specifically around multi-factor authentication and risky users. Swetha, you're up.
Thank you, Kelly. Hello, everyone, and welcome to this session on protecting your investments with Microsoft Managed Conditional Access Policies. My name is Shweta Rai, and I'm a product manager for Conditional Access here at Microsoft. The last session, we spoke on the top 5 recommendations on how to protect your investments, and enabling multi-factor authentication, or MFA, is number 1. Additionally, Kanika in the Azure Advisor session spoke on how enabling MFA is a security recommendation. In this section, I will dive deeper into MFA by explaining how Microsoft is helping customers to improve their identity security posture by providing them with clear, self-deploying, and continuously improving policies that leverage the power of conditional access. Despite the proven benefits of MFA, or multi-factor authentication, as one of the most effective ways to protect users and resources from cyber attacks, many organizations still struggle to adopt it widely and consistently across their environments. Some of the common challenges that we hear from customers are convincing leadership to invest in identity security and allocate sufficient resources, deploying and managing new policies without disrupting user productivity and experience, and lack of cybersecurity expertise and guidance on implementing best practices and addressing evolving threats. Kelly, if we could go back a couple of slides, please. Thank you. In the next slide, we're going to talk about when we talk to customers about how they would want Microsoft to help them evolve their identity security posture. There were 3 key points that came up from these discussions. Customers want packaged changes that are easy to deploy or not deploy, with information about the expected impact when deploying these changes to their environment. Large organizations want insights and recommendations from Microsoft that can help them leverage their own talent to make these changes for their business. In smaller organizations, admins both want the insights and recommendations from Microsoft, and for Microsoft to make these changes to protect their environment. In the next slide, we'll see why we decided to take a more radical approach to drive MFA adoption in enterprises. We started by requiring MFA for all consumer Microsoft accounts in 2013, and we saw significant improvement in security metrics and user recovery. Today, 100% of consumer Microsoft accounts older than 60 days have multi-factor authentication, and it's been this way for 10 years. We then introduced security defaults in 2019, which provides an on-by-default multi-factor authentication at no additional cost, and we applied it to all new tenants by default. In 2022, we started to apply security defaults to all existing tenants as well. In just the past year, we've turned on security defaults for 7 million new and existing tenants, and these tenants experience 80% fewer compromises than tenants without security defaults. However, we also recognize that security defaults is not a one-size-fits-all solution. Some customers need more granular control and flexibility over their security policies. That's why we're introducing Microsoft Managed Conditional Access Policies. Conditional access is a feature of Entra ID, formerly Azure Active Directory, that allows you to define and enforce policies based on various factors, such as user, device, location, app, and risk. For example, you can require MFA only for certain apps, or when the user is outside the corporate network, or when the sign-in is risky. Microsoft Managed Conditional Access Policies are created by Microsoft and automatically deployed to eligible tenants based on their licensing, usage, or other criteria. Customers retain full control over policy state and customization. In the next slide, we'll see the 3 Microsoft Managed Conditional Access Policies that we have rolled out related to MFA, and they all cover different scenarios and audiences. The first policy is called Admin Portals, and it covers 14 admin roles. This policy requires MFA when an admin signs into a Microsoft admin portal, such as Azure Portal, Microsoft 365 Admin Center, regardless of their location or device. This policy helps to protect these privileged admin functions. The second policy is for those tenants that use per-user MFA. Per-user MFA is when users are enabled individually and required to perform MFA each time they sign in. This policy applies to users who have per user MFA enabled on their accounts and requires MFA for all cloud apps when these users sign in. This policy helps organizations transitions from per user MFA to conditional access seamlessly, ensuring no disruption to end user experiences while maintaining a high level of security. The third policy is called risky sign-ins, and it covers all users in your organization. This policy requires MFA and re-authentication during high-risk sign-ins, such as sign-ins from unfamiliar locations, devices, or network. This policy helps to detect and prevent identity compromise and account takeover by requiring users to verify their identity when they sign in from a risky context. These policies have been created in report-only mode in all eligible tenants. You will have at least 90 days to review and customize these policies before they're enforced by Microsoft. You can opt out of these policies if you don't want to use them, but we strongly recommend that you keep them to get the benefit of enhanced security and the guidance that they provide. Now I'm going to switch over to a quick demo where I will walk you through how you can review, customize, and monitor these Microsoft Managed Conditional Access policies in the Entra portal. Starting at the Entra home, I will navigate to Conditional Access Blade, which will show you the 3 Microsoft Managed policies. As you can see, the first policy here is multi-factor authentication for admins accessing the admin portal. Each policy here has a set of recommended actions that we would expect you to take. It also has a detailed summary of the policy and what it does. And along with that, there is a section where you can edit and customize this policy. Here you can see that there are 14 admin roles that are included in this policy. And you also have the ability to exclude certain users, groups, or roles from this policy. This allows you to exclude your emergency accounts or service accounts that do not need to be prompted for MFA from this policy. You can edit this policy by clicking Edit here under Excluded Identities and navigating to either users, groups, or roles and selecting the user that you want to exclude from this policy. There is also a section on policy impact that allows you to see the number of users or sign-ins that will be impacted by this policy once this policy is enforced. Once you've made all of the customizations you want to make, you can go ahead and change the policy state. This policy is currently in report-only mode, which means that the policy is evaluated but not enforced, meaning it will not block any sign-ins for any reason. When you're ready to move the policy, you can change the policy state to on, which is the recommended state, or you can turn the policy off in the event that you have a similar policy already configured in your tenant. So I'm going to turn the policy on and save this policy here. Okay, switching over to the other policies on the other Microsoft managed policies on this list. The next policy we're going to look at is multi-factor authentication for users with per user MFA. Again, this policy has a set of recommended actions and a policy summary that describes what this policy does. In this case, this tenant has just one user that's enabled for per user MFA, and that user is included in this policy. You have the same customization options available for this policy as well, where you can exclude additional users or change the policy state at any time. The third policy, the third Microsoft managed policy we have is the require MFA and re-authentication for risky sign-ins. This policy, again, has a set of recommended actions that you could take and a description of what this policy does. All users in the tenant are included in this policy by default, but you have the same customization options where you can exclude certain accounts, such as emergency accounts, or service accounts, or any other accounts that do not have appropriate capabilities to perform MFA if required by this policy. This policy is currently in report-only mode, but it can also be moved to on-state just as any of the other policies. Now, one thing to note if you're familiar with conditional access policies is that the Microsoft managed conditional access policies offer limited customization options. In the event that you need to make further customizations, our recommendation is to duplicate the Microsoft managed policy, which will then create a custom conditional access policy that allows you to further customize it by adding additional conditions, such as requiring a specific location or a specific device type, etc. So you can duplicate this policy and then customize the new policy that's created. Now, in the event that these policies have not yet been, managed policies have not yet been added to your tenant, you can also create your own conditional access policies with similar requirements. You can either create a new policy and walk through the entire process step by step, or there is another easier method to do this where you can create a new policy from certain predefined templates that we have. One of the templates that's available in your tenant by default is the require MFA for authentication admins. You can select this policy and click review. And as you can see here, it brings up the option to rename your policy, set the policy state to whatever you need. We recommend starting with report only mode in most cases. It also targets the same 14 admin roles that we saw in the Microsoft managed policy and also requires MFA for these users. And then you can create this custom policy with just a single click of a button. Once this policy is created, you can then go back and edit that new policy and make any further customizations you want, including additional conditions, excluding more users from this policy, etc. All right. With that, that brings us to the end of my demo, and it also concludes the session on Microsoft Managed Conditional Access Policies. I hope that you found this session useful and informative. And to summarize, here are the key takeaways from this session. Microsoft Managed Conditional Access Policies are a set of policies that are created by Microsoft and automatically deployed to eligible tenants. These policies are based on the latest threat intelligence and best practices from Microsoft and provide customers with clear guidance on the expected impact and benefits of each policy. The first 3 policies we're rolling out are all related to MFA and cover different scenarios and audiences. You can review, customize, and monitor these policies in the Azure Entra portal, and you have 90 days to do so before these policies are enforced. Thank you for your attention and participation. And if you have any questions or feedback, feel free to reach out to me or visit the links in the resources that we'll share at the end of the session. Over to you, Kelly.
Thanks so much. So now we're going to close on our security chapter and pivot to Ben, who's going to wrap a bow around our entire session, covering best practices in the Azure Well-Architected Framework. Ben, over to you.
All right, thank you very much, Kelly. It's nice to have everyone on the call here and the webinar. My name is Ben Brower. I'm a product marketing manager and evangelist for the Patterns and Practices group here at Microsoft. I'm going to be talking to you today about the Well-Architected Framework. But before I start that, I'd like to tell you a little bit more about how the Well-Architected Framework powers the initiative around well-architected. If you could go to the next slide, please. Next one. All right, thank you. Yeah, so one back, thank you. So what we're talking about with the Well-Architected Initiative is that the framework is basically helping to support all of these different aspects of the initiative across Microsoft and mainly specifically within Azure, but it also includes other aspects of the Microsoft Cloud. So if we were to kind of go around this wheel here, what you see are assessments. I'll talk a bit about more assessments later in this slides. And there's a variety of tools. So Kanika mentioned the Azure Advisor product. It is aligned to the Well-Architected Framework, along with other products within Azure, so such as Azure Monitor and Azure Policy and Azure DevOps. These are all aligned to the Well-Architected Framework in a variety of ways. There's also a variety of other ways that you can use the Well-Architected Framework, or the Well-Architected Framework is included in these other aspects. One other area is skilling. Skilling is a really important area for the Well-Architected Framework because essentially what it's doing is it's helping you as a practitioner to learn how to design your architecture for your workload. So let's dive a little deeper into the 5 pillars of the Well-Architected Framework. What I'm going to do a little bit is just basically describe how to use the well-architected framework. So the design principles are essentially universal principles that any sort of workload could follow and that should be followed. And so what the goals of the design principles are basically to help develop a strategic vision where you have the product manager, you have the architect, and you have the lead developer working together to basically understand how to use the principles in a way that is supporting a specific workload. The other point to this is you want to make sure that this is high enough level where you're not necessarily talking about hands-on keyboard guidance here. And that's important because we will get to that sort of guidance. But at first, you need to really understand what this workload is meant to be, what sort of business requirements it's meant to follow or support, and also making sure that the outcomes are what you're expecting. This is particularly true when you look at things like reliability, where reliability and security, where both of these are meant to be shared responsibilities, but also to ensure that for a particular workload, the criticality of that workload, both reliability and security are at the appropriate levels. Next slide, please. So when you start to think more about those design principles and you're ready to move into the actual design of that workload, one of the things you'll want to do is, as an architect especially, is to be able to kind of look at all of the different recommendations for each of the pillars. So the best way to do that, what we've done with the Well-Architected Framework, is create a checklist of all the main requirements, the high-level recommendations that we would suggest you look at as you're going about the design. We make sure that this is concise and descriptive because what we want to do is make it easy for you to basically get through each of the recommendations, check the box, and move on. So the next slide, please. So once you're ready to kind of dive deeper into each of the recommendations, what you will get is basically very deep expert guidance on how to go about understanding this particular recommendation. So for each of the recommendations, what you'll get is expert guidance that is based on engagements that Microsoft has done with their customers. So our cloud solution architects, there's about 10,000 different engagements that we've basically went and codified into these different recommendations in such a way that you can use these as a way to better understand how to go about, one, configuring the different services that will make up the workload, and then two, how to go about ongoing development and ongoing use of those services. One of the important things that I also want to point out, this is going to come up in the next slide, is that when you think about the Well-Architected Framework, it really is about trade-offs, because what we're essentially trying to do is make sure that once you have a good understanding of what each one of these recommendations are for each one of the pillars, that there is a trade-off that you end up dealing with. And so this is kind of the last part of the story here, is that when you think about the reliability or security requirements or recommendations that are coming out of Advisor or coming out of the security controls that you see in the different screens that we saw today, you also want to take into account what the cost of these things are, or how they may impact your performance, or how it may impact the way you go about divvying up or making decisions for your organization. And so these sorts of trade-offs or considerations need to be part of the overall holistic review of how to take into account these different recommendations. And so the last part to this story is how to go about using the recommendations in a way that really matters. So if you can go to the next slide. Oh, sorry, one more to go. Service guides are one of those really important areas that help to kind of bridge between guidance and the product documentation. So last part here is the well-architected review. So the well-architected review basically makes it much easier to use the well-architected framework. The framework is about 1,100 pages of technical documentation. So the best way to go about using that documentation for your specific workload is to follow this particular type of assessment, where you'll have questions, answers, and then based on those answer choices that you choose, will give you certain recommendations. And those recommendations will essentially be links into the document itself. And so that'll make it very easy to basically make sure that you have all the information you need as soon as you need it. So thank you very much. And I'll turn it back to Kelly.
Thanks so much, Ben. And to all the presenters today from across the globe, we're here participating, trying to make sure that what we're conveying is interesting and valuable to you all. And Ben and Swetha, I just want to publicly say, please forgive me for messing up the slide advancements. But on a serious note, remember everybody, not everything in your environment needs to be configured for resiliency. Just those resources that your critical applications and workloads depend on. But everything does need to be secure. Sammy?
Yeah, thank you very much, and thanks to the speakers for the sessions. Instead of trawling through 1,100 pages of the well-architected framework, please, we want to take the opportunity to say, give us feedback on these sessions. We want these sessions to be great, but we also want to get better. So we do take feedback. My team and I read every little piece of feedback that we get, and we do, when we prepare the next sessions, we want to prepare them for you, for customers. And so here are some topics or ideas of things that we could do, but please, let us know what's good, because we want to build these sessions, as Kelly said, quarterly, in order to bring value and hopefully bring the well-architected framework to life. Anything else from you, Kelly? Thank you very much to our speakers and everyone, but I'm done. Thank you.
Yeah, no, thank you all. Huge shout out to the presenters, and thank you all for joining.
Thank you.